Okay, in this video, we're going to learn some introduction or basic probability. Okay, so I believe that every one of us already learned this basic probability during our secondary time. Okay, so I hope you can recall what you have learned. So under this topic, what you need to know are sample space, events, probability of an event, rules of probability, conditional probability, and the independent events. Okay. So if you refer on internet or any textbook, traditional examples that will be given to you or that you can found under topic probability is always about flipping a coin and throwing a dice, right? Okay, so this is very traditional example. Okay, now let's look at some introduction. So probability is the likelihood, or we can say that it is a chance of something happening and associated with situations involving doubt or uncertainty about the outcome. Okay, so probability is used as tool which allows you to evaluate the reliability of your conclusions about the population when sample information available. Okay, so normally we do not know what is the true value of population. So when we have sample, so based on sample we can do some sort of analysis to in order to conclude about population. Okay, so I hope you can recall back chapter 1, concept of population and sample. So the collection of all possible outcomes of an experiment is called the sample space. Okay. So later on I will explain detail about experiment and the sample space. Okay, in other words, it can be thought as a set of different possible outcomes. Okay, and each outcome can be thought as a point or an element in the sample space. Okay, for example, if you flip a coin, what are the possible outcomes? So normally we would say that either we will get a head or a tail. Okay, so that is the outcome. Different possible outcome, for example, so maybe first flip you will get tail tail, second flip maybe you will get tail head, third flip maybe you will get head tail. Okay, so that is an example of different outcomes. So thus, the concept of set theory provides a natural context for development of probability theory. So after this, we look at on set theory. Okay, now look at under set theory. Okay, look at some basic definition. Okay, the first one, set. So what is set? It is a collection of distinct objects. Okay, so each object in the set is called the element of the set. Okay, normally we use capital letter in order to denote set. Okay, for example here we have set A which contain of elements 1, 3, 5, 7, 9 and so forth. Okay, so we can say that 9 is subset of A. Okay, second one, null set. Null means nothing, right? Okay, so a set that has no element, so no element is called a null set or empty set. So subset here, suppose that A and B are two subsets and every element of A also belongs to set B. Okay, then A is called subset of B. Or we also can say that A is said to be contained in B. So this is how we write, this is symbol that we use for subset. Okay, sample space. The collection of all possible outcomes of an experiment is called the sample space. Okay, so every possible outcome, we call it as sample space. Then what is meant by experiment? So experiment is a process which generates a well-defined outcome that is not predictable in advance, but where we do know all the possible outcomes. Okay, so later on we see example. Means that we do know all possible outcome. For example, if we flip a coin, the possible outcome will be tail tail, tail head, head tail, or head head. Okay. So the outcomes generated by an experiment may or may not produce a numerical value. Okay, Okay, now look at what is an event. So event is a subset of the sample space, consists of the collection of outcomes that we are interested. Okay, now let's look at this example. The experiment is toss a fair coin 3 times. So previous example I mentioned before is if we toss a coin twice, okay, 2 times. Okay, so if 2 times, the possible outcomes are tail, 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 head, tail, or head. Okay, so this one 3 times. Okay, the sample space. So before that, so it is one way to get sample space is we can draw 3 diagram like this. Okay, so it is easy for you to get the all possible outcome like this. Okay, so this is for first toss, means that the outcomes will be either head or tail. Second toss also you will get either head or tail. So here also you will get either head or tail. Okay, so similarly outcomes under third toss. So based on this experiment, so what are the sample space? Okay, so we can write as, okay, as referring to sample space. So with this experiment, we will get, or the possible outcomes are head, tail, head, and so forth. Okay, until tail. Okay, let's say from this experiment, okay, we want to find elements of A if event A is observing 2 tails. Okay, so now we want to find set A. So what is set A? Observing 2 tails. Okay, before I continue, please do some correction here. So if you refer the elements in A here, so this one should be not 2 tails, okay, but 2 heads. Okay, so if based on this answer, but if you want to find 2 tails, means that from the all the possible outcomes, you find outcome with 2 tails. For example, here head, tail. So means that tail we have 2 here or twice. So the element under A observing 2 head, so will be head, tail. So 1, 2 head, tail, head. So 2 head here, and last one is tail, head. Okay, let's say I add another element. Let's say B, observing 1 tail. So B will be equal to, okay, what are the outcomes that having 1 tail only? 1 tail will be head, tail, tail. What else? Head, tail, head. Then this is 2, this is 1, tail, head. This one 2 tails, this one 2 tails, this one 3 tails. Okay, so these are elements if we observe 1 tail. We want to observe all tails will occur, so the element will be this one only. Okay, tail. Okay, now under operation of set theory, so what you need to know are the union, intersection, complement, the mutually exclusive events. So later on we will look at in detail. Okay, so for union, intersection, complements, we will look at in detail under rules of probability. Okay, mutually exclusive events. What is meant by mutually exclusive event? Okay, suppose that A and B are 2 sets. Okay, so A and B are mutually exclusive, or we call it as disjoint. If set A intersect B, so this symbol is intersection. So I hope you still remember. So if the intersection of A and B is equal to 0, then we call it the 2 events which are A and B are mutually exclusive. So mutually exclusive also, okay, we can define it as if both cannot occur at the same time. Okay, so if you look at this Venn diagram, okay, this is an example of mutually exclusive event. Okay, disjoint means that these 2 events is disjoint. Okay, for example, okay, let's say on Monday 8 to 10 you have class STA 108. Okay, so in the same day and same time, which is Monday 8 to 10 just now, you cannot go to science class, for example. Okay, so you only can go to one class only. So that is an example of mutually exclusive event or disjoint. Okay, so remember, mutually exclusive events, both events cannot occur at the same time. Okay, in contra, non-mutually exclusive event. Okay, so this one, there is an intersection between events. So this one, the rule, later on we will look at in detail. Okay, last one in your notes here, laws of algebra. So this one, no need to pay attention too much. Okay, so this one, I just give you extra note. And now last part is about Venn diagram. Okay, so I hope you still remember about Venn diagram. So I show you some example here. Union of two sets will be A union B. So means that everything included in A and B. Intersection of two sets. So this one will be the intersection, okay, between A and B. Complement of a set A. Let's say this is set A. So complement means that in BM is pelengkap. Okay, so means that this is A. So outside A is A prime. Okay, the complement. Okay, disjoint or mutually exclusive, as I explained before. So this is an mutually exclusive event. A and B are disjoint, okay, or cannot occur at the same time. Okay, now let's look at this example. If A elements in A is 1, 2, 3, 4, B 2, 4, 6, 8, and C 3, 4, 5, 6 are subsets of universal set. So the universal set U contain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, question A, it asks you to draw a Venn diagram for the above situation. Okay, so in this case, we have three sets, okay, A, B, and C. Okay, first, you list down all the elements that are intersect within each set. Okay, so meaning to say that what are elements under A intersect B? Intersection between A and B is number 2 and number 4. Okay, 2, 4, 2, 4. So these two numbers are intersect. So A intersect B, we have 2 and 4. Okay, next, find A intersect C. So A intersect C, so 4, 2, 3, 4. Okay, 3 and 4 only. 3 and 4. And last one, B intersect C. B intersect C also equal to C intersect B. So B intersect C, we have B intersect C. 4 and 6. Okay, 4 and 6. Okay, last one, we find A intersect B intersect C. So what is element under A intersect B intersect C? 1, 2, 3, 4, 2, 4, 6, 8, 3, 4, 5, 6. So the element is only 4. Now let's look at on how to draw the Venn diagram. So since we have three sets A, B, and C, so draw three circles to represent A, B, and C. So for example, this is A, so this is B. Okay, so this area will be, for example, here I put this is A, this is B. Okay, so this is A, this is B. So this area will be A intersect B, the red one. Okay, so this one is A intersect B. Okay, now the third circle will be 4C. Okay, let's say this one is C. Okay, now look at the intersection point. Okay, just now this is A intersect B. So here, this one will be what? A intersect B intersect C. Okay, so this part is A intersect B intersect C. Okay, look at carefully here. So this is C. So this is area A intersect C. Okay, so A intersect C. I put blue color here. So this is A intersect C. And last one, B intersect C. So this is B, this is C. So overlap area here will be B intersect C. Okay, now let's look at on how to put the elements. Okay, look at center point here first. Intersection of all elements, the pink one. So A intersect B intersect C is 4. So you put 4 here. Okay, B intersect C, green area. So the elements will be 4 and 6. So here we already have 4. So you just put 6 here, okay? So B intersect C. So here B intersect C. So this area is B intersect C. So 4, 6. Okay, A intersect C, 3 and 4. So A intersect C here. So here already 4. So you put 3 here. Okay, the element. Okay, last one, A intersect B. So here center overlap for all 3 sets already equivalent to 4 here. So here you write the element equal to 2. Okay, now look at each single element, each single set here, A, B, and C. So in A, the elements are 1, 2, 3, 4. So A, we have 2, 3, 4. So number 1, you just put here. Okay. Okay, next B, 2, 4, 6, 8. B, 2, 4, 6, 8. Okay. And C, 3, 4, 5, 6. So this is C, 3, 4. So 5 will be here. Then you have 6 also in C. Okay, now look at universal set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Normally how to complete this Venn diagram. So for universal set, normally we do like this. So this is universal set. Let's say I put U here, referring to universal set. So we have 1, 2, 3 until 10, right? So 1, 2, 3, 4, 5, 6, 7. So 7 you just put anywhere here. Okay, 7, 8, and then 9. And last one, 10. Okay, so this one will be universal set. So this is an example on how we label Venn diagram based on the question given. Okay, now let's look at question B. List A prime. A prime is not belongs to A. Okay, A prime union B intersect C. So again, you list first what is A prime and what is B intersect C. So A prime. So what are the elements under A prime? Not belongs to A. So A 1, 2, 3, 4. So union set just now is 1, 2, 3 until 10. So 1, 2, 3, 4 not belongs to A will be 5 until 10. So 5, 6, 7, 8, 9, 10. So what is B intersect C? So just now B intersect C is 4 and 6. Okay, now you can list elements under A prime union A prime union B intersect C. So now the elements will be, so union means you combine all, okay? So 5, 6, 7, lowest here is 4, so will be 4, 5, 6, 7, 8, 9, and last one is 10. Okay, for the following examples, example 12 and example 13, so later on you do it on your own and I will give the answer later, okay? Okay, now let's look at example 14. So the experiment given is toss a pair of dice, okay? So means that 2 dice. Okay, list all the sample space. Okay, so when you toss a pair of dice, so you will get all possible outcome like this, okay? So means that this is the first die, this is the second die. So altogether you will have 36 possible outcomes. Okay, so what are the outcomes? 1, 1, 1, 2, okay, like this. So when you toss that pair of dice, so you either get 1, 1, 1, 2, 1, 3, 2, 1, 3, 1, and so forth until 6, 6. Okay, so altogether you will have 36 different outcomes. Your answer you can just write like this, okay, 1 1 1 2 until 6 6. Okay, now let's look at question B. Let A be the event that the sum of the number is 4. Okay, example 0.13. 1 plus 3 equal to 4. And B, the event that the largest of two numbers is 5. Okay, so example 1 5. So largest of two numbers is 5. Okay, list A and B. So what are the elements under A and B? So A just now is sum of the number is 4. So you can write like this: A equal to 1 3 1 3. What else? Sum of the number is 4. 1 3 3 1. That's all right. Sorry, another one is what? 2 2. Okay, so another one will be 2 2. Any other elements here? Sum of two numbers is 4. 1 3 3 1 2 2. Okay, that's all. Okay, now B. Largest of two numbers is 5. Largest of two numbers is 5. So it means that 1 5 and then 2 5 3 5, right? 2 5 and then 3 5 and last one will be 4 5. So 5 5 is not included because 5 5 it is the same number, okay? But B here is defined as largest of two numbers is 5. So until 4 5 only. Okay, so that is some example of experiment and how we list all the possible outcomes.